This is the continuity of part 34. In 34, we saw Fourier sine transform of the given function. Now we are going to see Fourier cos transform of the given function f of x. Right? Given f of x, x lies between 0 and 1, 2 minus x lies between 1 and 2, 0, x greater than 2. That is equation number 1. To find the Fourier cos transform of f of x, see formula is f(c) bar of p, which is equal to root 2 divided by pi integral 0 to infinite f of x cos px dx. That is equation number 4. Using 1 in 4, so Fourier cos transform of f of x, f(c) bar of p, which is equal to root 2 divided by pi integral 0 to 1, because in 1 the function is splitted into 3 interval. So in 0 to 1 value of the function is x. In 1 to 2 the value of the function is 2 minus x, and 2 to infinite the value of the function is 0. So that is why we are going to split the integral into 3. First 0 to 1 f of x cos px dx plus root 2 divided by pi integral 1 to 2 f of x cos px dx plus root 2 divided by pi integral 2 to infinite f of x cos px dx. So substituting the values 0 to 1, in 0 to 1 x f of x value, so cos px dx plus root 2 divided by pi integral 1 to 2, in 1 to 2 f of x value is 2 minus x into cos px dx plus root 2 divided by pi integral 2 to infinite, so greater than 2 f of x value is 0, so 0 into cos px dx, which is equal to root 2 divided by pi integral 0 to 1 x cos px dx plus root 2 divided by pi integral 1 to 2 minus x cos px dx. Last integral is 0. Now this can be written as root 2 divided by pi integral 0 to 1 x into derivative of sine px by p plus root 2 divided by pi integral 1 to 2 minus x, the same one, derivative of sine px by p. So we are going to evaluate the integrals, so by using integral u dv formula. That is best to use Bernoulli's formula. So this is equation number 5. So Bernoulli's formula, integral u dv, which is equal to uv minus u dash v1 plus u double dash v2 minus etc etc. Here u dash u double dash are successive derivative of u, and v1 v2 are successive integrals of dv, right? So we are using this idea to evaluate the both the integrals in equation number 5. So in the first integrand, right, in equation number 5, u is equal to x and we are taking v is equal to sine px by x. Now du, u dash is equal to du dx, that is equal to 1, and v1 equal to integral sine px by p dx, that is integral v dx, right, which is equal to 1 by p integral sine px dx. So sine px minus cos px by p, so minus 1 by p square cos px. So now we are going to take the second integral, right, of the equation number 5. So here u is equal to 2 minus x and v is equal to sine px by p. U dash, that is equal to du, which is equal to derivative of 2 minus x, that is equal to minus 1, and v1 is same like above, minus 1 by p square cos px. So equation number 5 becomes, we are going to use this idea, that is Bernoulli's formula, to evaluate the integrals. So Fourier cos transform of f of x, which is equal to f(c) bar of p, which is equal to root 2 divided by pi. So first uv, Bernoulli's formula. So in the first integrand, u is x, v is sine px by p. So x sine px by p, limit is 0 to 1, minus next term u dash v1. So in the first integrand, u dash is 1 and v1 is minus 1 by p square cos px. So lower limit 0, upper limit 1. So minus u dash v1, that's all. So we are going to second one, that is equal to plus that is second integrand plus root 2 divided by pi. Here u is 2 minus x, v is sine px by p. So Bernoulli's formula uv 2 minus x into sine p x by p. Limit is 1 to 2, the second integrand, right? Then minus u dash minus 1 into v1. 1 minus 1 by p square cos px, limit is 1 to 2. So applying the upper limit and lower limit, so which is equal to root 2 divided by pi, upper limit 1 sine p1 by p minus 0 sine 0 by p, minus second term 1 by p square cos p into 1 plus 1 by p square cos 0. We are going to the second term, root 2 divided by pi, so 2 minus 2, that is sine 2p by p minus 2 minus 1 sine p into 1 by p plus minus 1 by p square cos p into 2 plus 1 by p square cos p into 1, right? So we are going to group this, simplifying this, so which is equal to root 2 divided by pi. First term sine p by p, sine 0 0, that is 0. Then second term minus into minus plus, so plus 1 by p square cos p, minus into plus plus, cos 0 is 1 minus 1 by p square. Next term plus root 2 divided by pi, 2 minus 2 0, so total term becomes 0. So we will get minus cos 2p by p square. Right, the second term 2 minus 1 1, so minus 1, so minus sine into p into 1 sine p by b, so first term, then minus 1 by p square cos 2p plus cos p by p square, that is 1 by p square into cos p. So now sine p by p, first one, root 2 divided by pi, multiplying with the root 2 divided by pi into first term sine p by p. And the second bracket we are having minus sine p by pi into root 2 by pi. So minus root 2 by pi sine p by p. Then plus root 2 divided by pi 1 by p square cos p. In the first bracket, second term root 2 divided by pi 1 by p square cos p. Similarly, we are going to take the second bracket, third term, right, plus root 2 divided by pi 1 by p square cos p. Then we are going to first bracket, third term, root 2 divided by pi into 1 minus p square minus root 2 divided by pi into 1 by p square. Then we are going to second bracket, second term, minus root 2 divided by pi 1 by p square cos 2p, right, which is equal to sine root 2 divided by pi sine p by p minus root 2 divided by pi sine p by pi, p gets cancelled. Then second and third term are same, so 2 times root 2 divided by pi 1 by p square cos p minus root 2 divided by pi 1 by p square cos 2p minus root 2 divided by pi 1 by p square. So 2 divided by root 2 divided by pi 1 by p square is common, take it outside, cos p minus root 2 divided by pi 1 by p square cos 2p. Before that we are going to use the formula, taking the common term. Before taking the common term, before that we are using cos 2p trigonometric formula, minus root 2 divided by pi 1 by p square, that is cos square p minus sin square p. Then last term can be written as 1 by root 2 divided by pi 1 by p square into 1, right, that is equal to 2 root 2 divided by pi 1 by p square cos p minus root 2 divided by pi 1 by p square, splitting that cos square p minus into minus plus root 2 divided by pi 1 by p square sin square p minus root 2 divided by pi 1 by p square. 1 can be written as cos square plus sin square, so cos square p plus sin square p, right. So which is equal to 2 root 2 divided by pi 1 by p square cos p minus root 2 divided by pi 1 by p square cos square p plus root 2 divided by pi 1 by p square sin square p, splitting the last term minus root 2 divided by pi 1 by p square cos square p minus root 2 divided by pi 1 by p square sin square p. So here root 2 divided by pi 1 by p square sine square p minus root 2 divided by pi 1 by p square sine square p, that is third and the fifth term get cancelled. So remaining you are having 2 root 2 divided by pi 1 by p square cos p minus 2 times, right, root 2 divided by pi 1 by p square cos square p, right. So Fourier cos transform of f of x, which is equal to fc bar of p, which is equal to 2 times root 2 divided by pi 1 by p square cos p, taking cos p outside, right, common term, 2 root 2 divided by pi 1 by p square cos p is common term in both, take it outside. In first term 1, second term cos square p you are having, remaining you are having cos p, so into 1 minus cos p, which is the Fourier cos transform of given function. Thanks.